Okay, when you get to a point where you can't get your model to work right, it's probably an indication that you're missing some steps. And I think the best thing to do is to start from complete scratch now with a new project, and this time go through um, all of the exercise, which is Lab 3 for OBS video. I'll start it like that, and that way I can review my problems there. So let's start out completely blank, and let's start with the easy tutorial that the professor in the GIS program gave. And let's see if, make sure we're recording okay. What have we got going on here? We got, yeah, everything's going on right there, and audio is going. Okay, so this is just cookie cutter, step-by-step recipe stuff. And so in this, one moment. All right, so here we have the step-by-step. So we're going to add data, and let's add data to the map. So let's just follow this along the way you would do. There is in map, add data, and then add data to the map. And then a folder comes up, and we have somewhere in here in downloads, we should have the, what was it called? Remember what it was called in us? Lab 3. So there's Lab 3, and we open the folder, and we're going to start with part A, and start with stow, and open it. And then it's got all of these things here that can be added to the map, and we'll say OK. And that data will be added, and boom, they come up right over there. And you can see if we go to schools and right-click and say to zoom to layer, boom, there's all the data that's available for this. Okay, so it's about processing that. And you're wondering, where is that stuff? Well, if you look under here, under folders, then down here there's lab, but that's not quite what we need. That just threw it on there. So I've got to figure out for a second where that database is, because this is what I just created. There's the folder. Probably
it says the extent we have to put down here. How do
probably the best thing for me to do is to right click and say add folder connection, and then find this lab 3 and make that a folder connection. And then I have access to it, and I can also right click and make it a default. And then I've got lab 3, and then there's part A, and you can see that part A had stow and all these things that I put in there. So there's a couple of ways we could have done it. If I take these things out, which I'm going to do, I want to just bring them in from the catalog, because I think that's a much better way to get started to it. So let's also remove that, and let's remove the elevation and leave the world hill shade and the world topographic map. So I'm going to go in here and I'm going to re-drag them, this time from my catalog, rather than going to add data. To me, that's a more robust way to do it. And it comes in. It's exactly what we had before, but at least now I know where it comes from, and I'm not going to get lost again because I've added it as a folder. So we've got all that data there. Let's go back to the instructions and see. Oh, and they're asking us to do that as well. So let's connect to the folder. So we wanted to go to add folder connection, and we didn't do that. They had us going to add data, and it should have been add folder. But I'm going to show you could have added data in there. You can see it folded there. So when it's a folder connection, they're saying that when you go to add data, then if you add data, then it'll come up. But we've got it in there. All right. The next thing we're going to do is project folder, there's a data folder, and there's another project folder, part A, and then it's asking us to save from the quick access toolbar. So let's follow that and go to here, hit save. So it teaches you how to save your project. Then finding a site for a new school, making a suitability model. It's going to take us 45 minutes. Let's see if it really does. It's 4:12 right now. Let's see if by 5 o'clock we're done with this. So create a new toolbox in the Part A folder called Site Analysis Tools. And so new toolbox. All right. So let's go here to, and how does it say to do it? It says to go to Part A and say new, and then toolbox. And that new toolbox shows up there, and we're going to name that toolbox. Creating a new toolbox, name it Site Analysis Tools. So let's copy that, come over here, and rename this Site Analysis Tools. I guess that's so you have your handy site analysis tools all in one place. So the next part is to create a new model, and we're going to right click on it and make a new model in those tools. So that's the idea, is that you create a toolbox for a specific task that you want to do, and then in that build your model so you have it available. So here we go, new model within the toolbox, and it'll be available to us in there. And I think we should name that. It probably is going to ask us to. Model properties, find school. So rename the model. On the model's main menu, click model, model properties, and then it'll be find school in both the name and the label. So we're going to come up here in the model builder, and we are going to properties, and we're naming it find school, and label find school. It doesn't say anything about relative paths, because it says check the store tool with relative path, but that does not exist. So it says if you don't see this checkbox, skip it and move to the next step. Normally we want relative path names, but it doesn't have it. All right. So we don't have that anywhere. Nope. So just say, okay. So now we have a model. I'd like to give this model a name here, tool. So I would keep things consistent, and it seems, no, what does it seem? It doesn't seem like there is a way to name the model. The model is just a model, but it's called find school. Okay, so here we can't get the name to be changed. All right, fair enough. And by the way, this is going to go to the right side. And whenever this happens, if you get something that looks like it's out of dock and you don't want to try to figure out where to dock it, it does come up like this, and you can say, okay, do it right there, and then it docks fine. But you can always go back to the view and go to reset panes for mapping. And then everything is good in terms of the panes. All right,
It's not working.
I know, that's why we're going through it from the beginning. Specify environment settings. So before you do analysis, you want relevant environmental settings. And that's one of the problems we may have had set environments between analysis environments.
Yes,
So we're doing the process of this
How do
model
you
only,
change
so we're
that?
setting the model,
Can you
this
help me
model.
one here?
All right, so it says to generate a new geodatabase because the environment settings apply to process this model only. You'll set environment settings
But I
to
just
the
go
model.
into the beginning to it.
All right, so I'm going to right-click on Part A folder in Catalog and generate a new database, and it shows us exactly what to do here. And make a new file geodatabase, and we're going to call it Scratch. Still unclear as to why they want us to do that, but we go to Part A, and we go New, and we do File Geodatabase, and we call it, I hope I'm doing this right, Scratch, but that doesn't look right. Is that what it said to do there? Scratch GDB. Rename it. So File, not folder, New File Geodatabase, Scratch GDB. So I'm doing something wrong here. Oh, there it is. There's the new file database. So I didn't want to do that. Part A. So this is the new database, and it says to name it. So we're going to go in here and name this Scratch. Somebody's going to have to explain to me why this is even necessary. Actually, I can't get in here and do anything. That's funny. All right, something's odd. How do I change the name? You go to, I thought it would be by going to Properties and rename. All right, let's do that. Let's call it Scratch. And it comes in as a scratch.gdb. What do they give for the reason for Scratch? It says you should set any relevant environmental settings. You'll set environmental settings for the model, and then it wants us to generate a new geodatabase and name it Scratch. All right. Set the workspace to Scratch. You need to click on the folder button and navigate to folder, Part A, and select Scratch GDB. And then it'll be the same as the layer elevation. That's going to be the extent that we're going to use. All right, so we have Scratch under Part A. And when we select it, we then go to Environments under the Model Builder. And it should be Current Workspace, Scratch Workspace. Let's see what they're saying here. The current workspace is Lab, and the Scratch workspace is Scratch. I guess that's so you don't damage things. So let's make this one Scratch for the Scratch workspace, and then the processing extent is going to be the same as the elevation. Maybe that's what my wife is going through too. Yep, set it to the elevation. And the cell size has to be set. So these are the things that are in Part A. We had to set, the reason they made a Scratch thing is you could set the environments to layer elevation for the extent and the cell size the same as layer elevation. So everything was ruled by the DEM. So that was the idea of using the Scratch thing. So you have a workspace and you've got a Scratch workspace. And both of them, I guess, you're setting the extent to elevation. And that's then specified. And
no, it says to boundary, not elevation.
not in this one. This is, I'm doing the Part A. And the cell size, again, is same as layer elevation. And then, oops, let's put it like that. And like that, so good. And then, once we have that, choosing a cell size in advance will avoid random changes of cell size in the model, which may affect the data quality. So click on OK and then save. So we're really going through this slowly to make sure that everything works out. Now we hit save for the model builder, and we are okay there. The model's properties are updated. If you want to further edit the model, right-click on the model catalog window and click Edit to continue with the tutorial. All right, deriving data sets. You're ready to start processing your project data, locate suitable areas for the new school. Derive slope, derive distance from recreation sites, and derive distance from existing schools. And so we're going to put in slope, Euclidean distance, Euclidean distance. You only need the distance raster among the three outputs. In Euclidean distance, you can ignore the other two, leave them gray. So we know that we can do that, and this is fairly simple, except that the input raster is joined, and then we are going to open the slope tool. All right, let's add them first. So for our model, we're going to go to the tools in analysis and call that up, and we're going to find slope and use the spatial analyst, not the 3D analyst, and drop that in. And we're going to find Euclidean distance. And again, use spatial analysis. I think we need 2 of those. So let's drop those in. And let's just make sure that when we are looking at the model that we auto lay out those and fit them to the window. All right. So the question is, what are we doing the slope on? Well, the slope goes on to the elevation. So drag the elevation in here, and the Euclidean distance is going to be from the roads, I believe. Let's see again what they want in there. They want us to have schools and recreation sites. So that's what we're going to use. Okay, so going in and dragging in schools and recreation sites. And then take elevation and drag it to slope and say input raster. Take schools and drag it in, input raster, and Euclidean distance and input raster there. Next step. We've added the connection, and we're using input raster or feature source data for both, which is fine. Auto layout. And we want to navigate a long prefix. So navigate to the last backslash, name it slope out or slope. So copy, and then take this and rename this to slope out. And then it also said that when you do this, you could double click on it and you may find this whole thing there, and maybe want to put slope out in there as well. Oh, but what happened here? Didn't really like that, did it? So that was weird. Why? Oh, I don't know, so I'm not going to mess with it. Although that's what it says to do. Note the path may not be the same as the path in the computer. Meaningful name of data, Z factor. Okay, so we do have to get in there and get some stuff in there. So let me get rid of this and let's put this in again, just in case there was a problem. So slope, elevation goes into slope, input raster, and then here we double click and we put slope out. There's a period, that might have been the problem. Say OK. But properties, oh, there are no properties. Oh, in here. So the elevation output raster is going to be slope out, and then the Z factor is supposed to be 0.3048. And that is to convert the Z values to the same unit of measure, the XY units, from feet to meters. You need to do this because the height and cell size of the elevation raster are in different units. Oh, okay. Height and cell size are in different units. So we've got feet apparently, but the elevation is in meters. So we've got to make the z factor, which is the elevation, 1.308. Okay, well that's a critical thing we forgot in the part B.
What?
Well, that you've got to type in the z factor for the slope when you're doing slope, because they're different, they're feet and meters. So that's a mess.
What's slow?
Yeah.
Um,
When you open up the slope thing.
yeah.
Mm-hmm.
Where is that in the Z factor?
Yeah, z factor, you type in 0.3048.
3.
048. Alright, because this all builds on each other. Then rename it as slope output
Really?
and hit enter. Okay. Renaming an element caution label does not alter the name of the output on disk. A layer will be added to the context references. Alright. Deriving distance from recreation sites. Now we want to hover over there, and you see all the defaults are fine, and it says you accept the default for the maximum distance, thus leaving this parameter empty. Therefore, the edge of the output raster is used as the maximum distance. The output cell size is taken from the environment setting, previously set to that of your elevation data. In this exercise, the output direction raster is not required, so we're going to name it output distance raster is going to be called distance to recreation sites. Okay, so save ourselves some typing, and we are going to go to the model, and from the output distance raster, it says we don't have to do anything here. In fact, it was just a hover over, and then it shows you that it is got the right elevation as the output cell size, the distance raster is that, and distance matter. So what we're doing is taking this name and renaming it to output distance raster, naming it, it's supposed to be more than distance, wait a minute. What did I get? Distance to recreation sites. It's probably still in there. If not, distance to recreation sites. Alright. It doesn't ask us to change what's underneath the hood. If we wanted to, we could, but then you would have to go into here and say distance to recreation sites. If I want to do consistency. Alright, got that. Coming back. Now the distance from schools. Hover over it. You can easily see the default parameters. There's no need to adjust any of them. And we're going to call this distance to schools. And so let's do that. Let's check this and go. I'm going to change this name too. And I'm also going to, oh, it does change it there. Interesting, you can do it both for the thing that's saved and what you have for the label. So, bingo. All right, then, let's save this, model builder. And then once we've done that, we have to have add to display, so it will be added to display each time the model is run. And then we're going to save and click the run button to execute the 3 tools, and its progress is going to be documented, and it's going to highlight in red, and then close it. All right, so going to here again, we can now hit validate, fine, and hit run. And I can say close on completion, and as they say, it turns red as it's running. and tells you the order it's running, and then turns a gray line under each of these saying that it has made an output, and we didn't hit add to display like they said to, so I'm doing that post hoc, and distance to schools. If I'd done it pre-hoc, then it would have appeared. So now when I open up my map, I have the distance to schools, I have the distance to recreation sites, and I have the slope in there, where 90 degrees is the darkest, and the lowest slope is the white part, as is evident. And as you can see, it is matching what the expectation was. The steep slopes are displayed in red. Well, my slope is not in red. As long as the patterns are the same, they should be correct. So let's go back here. Let's also move our schools above in the model, so that those 2 dots, 3 dots, they appear as schools. Let's bring our recreation sites in there. Those are all our rec sites. Let's bring our destination up there, and let's bring our roads up there. All right, so we got our road network. Probably this is a good time to differentiate our schools from our destination and our rec sites. So I'm going to click on the symbology, and rather than use this symbol as it is, I'm going to go into the gallery, and I think they do have school in here. It says there's 372 schools down there. Come up, there we go. School crossing, school, 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 icon point, school, push pins with schools. So let's just use this ArcGIS 2D, and bingo, we get schools in there, and they're easy to see. And then in terms of the properties, then we can do scale-based sizing, and we can bring them down to 10 on here and apply that. And that way when you zoom in, they retain their size so they don't overwhelm you. If you don't like that, then bring it up a little bit. Bring it up to 25. And now, yeah, they come up.
Something, Dave and I go to the store.
All right, so we have our school legends like that, our rec sites. Oops. Okay, commit that. And then our rec sites, we also want to go to symbology, and let's see if they have something for recreation. And double click on it, go to the gallery. Football, swing, teeter, playground. I kind of like the, I'll put playground in, because that's what my kids would like. So there's all the recreation sites, and then when we go to the properties, we can do that as well, and apply it. And then we can see much better where the schools are and where the recreation sites are. And there's a lot of recreation sites, and there's a few schools. There's 2 schools over there. One seems to be right next to a recreation site, right? So that gives us a much better way of looking at this. I think these recreation sites are a little too big. Make them half the size of the school. That way the schools loom larger. It makes it easier to see. Let's do that a little smaller, make it 6 point. Color's fine. Let's apply it. There we go. All right. So we got recreation sites dotted on the landscape. Let's go ahead and save this, and let's go on to the next thing. All right. On the slope output layer, steep slopes are displayed in red and less steep slopes are in green. In the output layer, distance increase the farther you are from a recreation site. So distances increase the farther you are from the school. And you can use color ramp condition number to show a similar result. Color ramp condition number. So in terms of these, the slope output was definitely, let's turn these off for a second. So that's not the same color ramp. So the color scheme was supposed to be, and let's see again what they say, color ramp condition number. Color ramp condition number. Classify. So I don't know where they mean color ramp condition number, but one can certainly go to this, and that looks more like what they had. In fact, it looks identical to what they have. All right. So we've got that, and we see that 90 degrees, the most dangerous things are in the mountains there. Similarly, when we look at this, we are using a different color ramp. So let's come here. That color scheme is a not as defined one. That one is much more defined. And so we're fine with that. And that's under stretch. So if we don't want to stretch, we could use classify. That looks like that. Yeeks. We do this color scheme for that. Then we get something that's yicky. Theirs is a little bit more stretched. So maybe we want to use stretch, but we want to use a more discrete form of it. And then there's a percent clip that can be done, or we can do minimum maximum, or we can do none, or we can do standard deviation, or we can do histogram equalize. So I'll just do min-max for now. And you can edit the min-max values. I don't want to do that. I think that's fine for our purposes here. And then for this one, similarly, they made it in a nice color scheme that was not as harsh. So let's find, that was under stretch. It's not too bad. I think I'm going to leave that because you have all this ability to, there's no unique values. Stretch. All right, I think we're okay with all of this now. So saving and moving on, we get to reclassifying data sets. So deriving data sets such as the slope is the first step in building a suitability model. Each cell in your study area now has a value for each input criteria: slope, land use, distance to recreation sites, and distance to schools. You need to combine the derived data sets to create a suitability map that will identify potential locations for the new school. However, it's not possible to combine them in their present forms. You can't combine a cell value which slope equals 15 degrees with a cell value for land use that equals 7, forest, and get a meaningful answer that you can compare to other locations. To combine the data sets, they first need to be set up to a common measurement scale, such as 1 to 10. And that we're going to use for all these exercises. So the common measurement scale is what determines how suitable a particular location each cell is for building a new school. Higher values indicate more suitable locations. 10 is better. Using the weighted overlay tool, you can weight the values of each data set and then combine them. However, the inputs for the weighted overlay tool must contain discrete integer values. Land use data is already categorized in discrete values. Forest equals 7. So you can simply add this data set directly into the weighted overlay tool and assign each cell a new value on the common measurement scale of 1 to 10. We'll do this later in the tutorial. The values in the data sets you derived in previous steps are all floating point continuous data sets categorized into ranges, and they must be first reclassified so that each range of values is assigned to one discrete integer value. Potentially, the values given to each range can be any number, provided you note the range that the value corresponds to. This is because you can weight these values within the weighted overlay tool, the next step after reclassifying derived datasets. However, it's easier to weight the cell values for derived datasets while reclassifying. In the weighted overlay tool, you can accept the default and leave the scale values the same as the input values. Okay. The reclassify, so it looks like we're just going to use the scale in weighted as whatever the input values are from reclassify. So reclassify to a common measurement scale, giving each range a discrete integer value between 1 and 10. Higher values will be given to attributes within each data set that are more suitable for locating the school. So we want to add reclassify in there. So we're going to drop it in, spatial analysis, not 3D tool, and then add another reclassify tool to recreation, and then slope output to reclassify, and distance to reclassify, and then we're going to do auto layout. All right, so that's pretty straightforward. So we're going to come in here, and we're going to find our reclassify tool for spatial analysis, that one there. We're going to go to our model. We're going to go U, reclassify, U, reclassify, U, reclassify, U, go, input, U, go, input, and U, go, and input. Now, save that. So our model is going to reclassify all this. And now we're going to go to our auto layout. Oops. Fine if you want to do auto layout. Boom. And fit to window. Boom. Fine. Now, reclassify. It's preferable that the new school site be located on relatively flat ground. It'll reclassify the slope output, slicing the values in equal intervals. It'll assign a value of 10 to the most suitable range of slopes, those with the lowest angle of slope, and 1 to the least suitable. So 10 is great. 10 out of 10. Give a 10. Oh dear. Those with the steepest slope and rank the values on the list. So open reclassify, and reclassify. Your value will use classify and do equal interval. All right. So we go here, and we go to reclassify of slope, and we tell it that we want to classify, and we tell it we want 10, and we want it to be equal interval, and there we have it. All right. And now we want to reverse the new values so that 10 is the best because it's the lowest slope. So here the lowest slope is a 1. So we need to reverse the new values. Now 10 is the lowest and the worst is 42 degrees. And I think that's all we do for that. Accept the default name for the output raster and say OK. So reclassify slope as the output raster. OK, here we go. All right, next. Distance. Schools should be located as close as possible to a recreational facility. We will classify the distance to recreation sites, assigning a number 10 to ranges of values that are closest, that's the most suitable, and 1 to the ranges that are the farthest, the least suitable, and rank values. And so we're going to do the same thing, reclass, and let's try this. And let's see. Unlike the wolf experiment, where the wolves want to stay as far away from people and roads, this we want to be closest distance to the recreation sites. Oh, did I get that backwards? Excuse me. This is named wrong. This is distance to schools. Glad I noticed that. Ooh, it ain't gonna change because it's written here. So distance to schools. Oh my gosh. Yeah. This is schools. schools. Has to be the H. So little things like that can mess you up a bit. And it's schools until I've changed this. So this has got to be distance to recreation sites. And then I can change this to recreation sites. And then this can be changed to schools from schools. All right, so almost made a mistake there. This is now distance to schools, and it needs to be classified again because we changed it. So we want to go here and say, once again, 10, and do equal interval. And then we want to reverse this, I think, because the distance is supposed to be great if it's really close to the school. So boom for that. Remember, this one still has the lowest slope being a 10. And we'll have to do the same thing here. Distance to recreation sites, and bring this to 10, and bring this to equal interval. And once again, the closeness to the recreation site is of high value. And that should be good. So, output raster, recreation classified tool, the recreation sites. For some reason, theirs had school recreation sites. I don't know why they did that first, but they did. And then right click, distance to schools. And so it should be the same thing. Schools. It's necessary to locate the new school away from existing schools. Oh, to avoid encroaching on their catchment areas. That's a wrinkle. Reclassified distance to schools layer, assigning a value of 10 to areas farthest from existing schools. That's the most suitable. Assigning a value of 1 to areas near existing schools, which are least little, and ranking in to determine the areas which are near, which are far from existing schools. So I did that backwards. The schools, distance to schools area is the farther away, the better. That's why we should not have reversed that. I was not paying attention. So let's go to the distance to schools and reverse that. So now the farther away it is from the school, the better it is. All right. Then it tells us to run the tool. Right-click each of them and add to display, and then click the Run button, and then we'll click the Save button, and then they'll be added. All right. So let's go ahead in here, and we are going to make sure that we tell this to add to display, tell this to add to display, tell this to add to display, and you'll see that there's a little green check mark next to it. And now hit Run, and it's calculating, and it's calculating. It's doing the whole model now. And you see how it's calculating. Now it's classifying the distance to schools, and now it's classifying recreation sites, and now it's adding everything to the model so that when we look at it now, look at that. Reclassified distance, and that's surrounding, as you can see, it's an ugly thing, isn't it? Because we didn't tell it what is reclassified to what. That's obviously the recreation sites. And this is the what on earth? And that's the reclassified slope. So the reclassified scope, I mean, they're all wiki-wacky. so we can't really tell. So we know the slope if we go to properties. I don't mean properties, I mean symbology. If we go to symbology for the slope, we can take it and make it a, and it's still unique values, but we can make it more like this. And then we get a heat map that says that if you are on a flat area, you're doing best, and if you're not, then you're doing worse. That's weird to me though, because it's supposed to be the best. Oh, the best is, okay, the colors are messed up because the flattest is the one that we said would be 10. So this has got to be reversed. So we go to more and say symbols reverse order. That's much better. Those are the steepest areas. The green is the best. Okay, so that's the reclassified stuff. And you can see that the schools are in the best areas. They're not on the mountain. Now, when it comes to this class here, this is so whacked out. Once again, if I go and I say the color scheme is going to be this, then this is the distance. Something seems to be wrong here. Go back to my model. So distance to schools is schools Euclidean distance, and then we reclassified that and we said that if the school is near, then we don't want to be any part of it. And that's when we ran this one here. So I'm going to rerun this, but I'm also going to reclass slope. I want to rename this because this is getting hard to understand. Reclassify distance to school, and there's that. And then this one is reclassify distance to rec. And I'm going to rerun this individually. And then it says, there's reclassifying that. And I'm going to rerun, what was that? That was to school. I'm going to rerun this. And it seems that because they're new names, it's keeping all that other garbage. So I need to get rid of this. I want to get rid of this. I want to get rid of this. All right, so let's run this again. In fact, let's run the whole Lincoln model again. Slope will be calculated. Let's remove that. Let's get this out of here. Let's get this out of here. And we keep our land use. All right, so now when we run the whole model, a whole lot of nothing happened. Validate it. What's wrong? Run it. Okay. So it says the school does the Euclidean distance to the recreation site, it does the slope, and then it runs the reclassify for the elevation, and it's going to pop that in, and it runs the reclassify of the distance to the schools, and it runs the reclassify distance to recreation. Great. So now that all these things are in here, it still doesn't, distance to recreation. Okay, so if we look at the distance to recreation, then we see all these wacko colors. We don't care for those. So we're going to go yay. And then we'll say that distance to recreation, the closer it is, the better it is. So we need to reverse those. Okay. And then we're going to come into here and we're going to say distance to schools is supposed to be such that if you're really far from the school, you're better off. So let's go here and say reverse values. And those are very, if you're close to the school, your highest value, your green, what is good is being as far from the school as possible. And then there's various other intervals, but equal intervals seems kind of weird. I don't know why that's not working well, because it should be like this. Right click on the layers to change their color schemes to stretch. Alright, so don't use classify, use stretch. Alright, I'm using stretch, and I'm going like this, and it still looks really, really weird. So it seems this is the vulnerable area. I'm not sure how one makes this work so that it looks like what they have. Standard deviation. No, everything that we're seeing here is massive in terms of the symbology, the distance to school, and it should be, of course, that the, let me see if I reverse this. I mean, I must be doing something wrong in terms of that, because this one is perfectly right. That is exactly what we want to see. The schools should be red on the inside and then going to the green, and it's not working. So something went wrong in the reclassify the distance to the schools. So the Euclidean distance says here some warning. Output distance exists, it will be overwritten. Well, that's okay. We don't mind that. And the feature is schools, and the output is distance to schools. It'll overwrite it, and then the distance to schools is there, and then the reclassify is supposed to be that we use an equal interval. Maybe that's the problem. If we do that and we say that the farther the schools away are, then the better off we are, and then reclassify distance to schools and say OK, and then rerun the distance to schools. That's the reclassify there. So this is distance to recreation. This is reclassified distance to schools. I think now this one here we can remove. And this one here, yes, this is going to work now. So that must have been the problem. And so now when we go to this color ramp, yeah, and it's supposed to be red, is it not? Yes, because we want to make sure that the farther the school away is, the better it is. All right, so now we've got something that works. And we've rerun that, can run this, we got that. So that's the distance to recreation. And the slope, we reran and we got this weird color scheme. So let's make sure that the slope is a stretch value and that we are using this color ramp. So you're really thinking through what those distances mean, and we'll invert that color scheme. So yeah, that's where that's where we want the schools to be. So the suitability analysis is going to say, yeah, green is good here. Nobody wants to be out in the mountains where the slope is bad. And then here, the green is good for where you want to be related to recreation, but you want to be as far away from the schools as possible, so the schools aren't encroaching on each other's territory. So we've got that, and it's looking okay. And now it says that we weighting and combining data sets. You are now ready to combine the reclassified data sets and land use to find the most suitable locations. The values of the reclassified data sets representing slope, distance, recreation sites, and schools have been reclassified to a common measurement scale. More suitable cells have higher values. The land use data is still in its original form because you can weight the cell values for this data set as part of the weighted overlay. And then values representing areas of water and wetlands will be restricted. You can also mark slope values that are less than 4, least suitable because they're too steep, as restricted, so these values can be excluded. And if all data sets are equally important, you could simply combine them, giving each equal influence. However, you've been informed that it is preferable to locate the new school close to recreational facilities and away from other schools. So you're going to weight the inputs, assigning each percentage an influence. The higher the percentage, the more influence a particular input will have in your suitability model. So we're going to do 50% for the distance to recreation sites, 25% for the distance to schools, 13% for reclass slopes, and land use will be 12%. And we're going to put in a weighted overlay. So we are going to add the land use raster to the model. All right, so the land use raster is here, and we didn't put it in the model yet. So let's take our land use raster and drag it in. All right. And we're going to also put in the weighted overlay tool. So we go here and we find the weighted overlay. There it is. And drag that into the model. Maybe I'll put it here. And then I believe we're just going to drag everything onto that. And we're going to open it, and we're going to drag the outputs and land use toward weighted overlay. Choose weighted overlay table. So that goes into there, and that goes into there. This is the fun part. That goes over there, and that goes into there. Now, when we open this up, we can start assigning to it. And we've been told that we're going to do some of the influences. Default evaluation scale is from 1 to 9. We want a scale of 1 to 10, so we need to update that. So change this from 1 to 9 to 1 to 10. All right. Now we want to, looks like we're going to have to assign some of that. That looks messy. So we're going to have to rewrite this part here. May need to update the values to be the same as the value comment. And we'll have to do that. How do you do that? Can you field value? I guess we're going to have to remap it ourselves. That's unfortunate. 1, 2, 3, 4, and this should be 5, and this should be 6, and this should be 7, and this should be 8, this should be 9, and this should be 10. All right, and then we're going to mess with the classification for the weighting, and it said to put 50% for rec, 25% for school. So distance to school is 25%, 50% is recreation. You can see now we're adding to 175%. So we've got to make the slope 13 and land use 15. So the slope is 13 and this is 12. That makes 100%. For the reclassified, click the cell with a value of 1. You can modify, the scale mode mix the field column because the evaluation scale is set to encompass the range of values in each input raster. You could modify the scale for each class at this point. For this input, the values are already rescaled appropriately at the time classifying. For the reclass slope in the scale column, click the cell with a value of 1 and then click restricted. Values from 1 to 3 will be restricted. Alright, so 1 is going to be restricted. 2 is going to be restricted. Oh, that's not for land use. Wait a minute. Let's see if these things change when you click on each one of these. So the slope, 1 is restricted, 2 is restricted, and 3 is restricted. Those are way too steep for a school. Then that's the slope. If you're restricted, you know you don't want to build on slopes greater than about 30%, even if all the other conditions are ideal. So your restricted values from 1 to 3, since they represent slopes over 30.96% of maximum slope. So they show us how to do that, which is great. Dive in. Setting a scale to restricted assigns a value to that cell in the output weighted overlay result that is the minimum value of the evaluation scale set -1. There are no inputs to the weighted overlay tool with cells with no data. You could use no data as the scale value. Or if you have no data cells in any of your inputs, it's safe to choose restricted. Potentially, a result from the weighted overlay tool could contain cells with no data that have come from one or more of the inputs, and restricted areas that you intentionally exclude. No data and restricted should not be confused. Each serves a specific purpose. There may be areas of no data for which you don't know the value, but they're actually suitable. If you use no data to exclude, then there's no data in one of the inputs. You won't know whether it means the area is restricted from use or there will be no data. So let's use restricted instead of no data. That's good. Click on land use and change the field from value to land use. All right, so when we click on land use, then we know that we need to be able to see the land use. We go from value in this field to land use. And then we're going to set in here our bush to 5, barren land is the best, 10. So 5, 10, 3, 9, 4, if that's the way it goes. No, it's not the way it goes. So 5 is bush. 5 is what? Yeah, 5 is bush transitional. Barren land is the absolute best. It's here. And water is not suitable at all. So for water, it doesn't even say, but water and wetlands will be restricted, as we saw. So no. Wetlands, no, we don't want to build on a wetland. And now we have barren land is 10, built up 3, agriculture 9. Built up 3, agriculture, pretty good. 9, forest, I don't think we should build on the forest, but they say 4. So they would clear forest to build these schools, those jerks. And that's it. All right. So you'll assign an influence to each raster and how much it should have. In the percent column, we did that already. All right, so that's in. And then we say OK. And we're going to name it suitable areas. So here then we say OK. And we are going to call this suitable areas. Okay. And we're going to right click on it and say add to display. And then we're going to run it. And it's taking all these values that came from these that we've already run that have the shade on it, and it's put it on there. And now we have a suitable areas on the map. And the best suitable areas might be backwards. Let's see. Yeah, they are backwards. All right, run the model, click Save. Examine the layer. Setting the color stream will appear a similar result. Locations with higher values indicate more suitable sites. So our thing is obviously backwards, again, for whatever reason. So when we go here, let's save first. When we go here and go to the symbology, we can tell it to be a stretch. And we can tell it to be here. And then the suitable areas are appearing in green. And I'm not seeing how to get the legend on there. Symbology, data. So it doesn't, does it tell us how? No, it doesn't. On your layer, each pixel has a value indicating how suitable that location is for a new school. Pixels with a value of 9 are most suitable. Pixels with a value lower are not suitable. The optimal location is a value of 9. Suitable location should be a contiguous area with a value 9. But how do you make it so that you can see the legend? This I do not know. But be that as it may, we are seeing, even if I did classify, that's whacked. There's only 4 classes, and there should be 10. But maybe there aren't. Unique values. Now if we do unique values and tell it to do this color, it's a little bit better. And there's the legend there. So isn't that, if 9 is red, I thought that 9 was supposed to be green. So something is backwards about this. But now we're not getting green like they're getting. What did I do wrong? If 9 is green, and in here, I've got to go and look at this. This is really messed up. So I'm going to get rid of that again. That one looks right. And that one looks right. And we're really looking at the overlap of that and that. And the also looking at the slope. So all those are correct. We go back to our model. Then we have the reclassified slope, we have the distance to school, we have the distance to recreation, and we have the land use. And in this, we had said that land use was 12, that the distance to recreation was 50% of it, and then 25% was that. We restricted the distance to school, scale. This got messed up. Oh boy, did it get messed up. Look at that. So something's wrong here. This should be 9. This should be 8. This should be 7. This should be 6. This should be 5, 4, 3, and this should be 10. So that probably is what caused this problem. And here we have the brush, Baron, that restricted. We've got this. Oh, this is messed up as well. So it looks like things got really messed up here. This has got to be 10. This has got to be 9. This has to be 8. This has to be 7, etc. 5, 4, 3, 2, 1. All right. So now let's try it again and run it. So these are the kind of problems that you may find. Now 9 is going to be green, and so when we look at this on the map, there we go. That's looking a lot more like what they show there. Okay, so we've had some success there. Time to save the model. It's good these things are happening. When things go wrong, that really does help you to recover from the problems that you're having by seeing what can go wrong and where it can go wrong. So I consider that a success. Now that we've run those weighted overlays, we're going to do a majority filter. Yes. On your layer, each pixel has a value that indicates how suitable it is, and therefore the optimal is 9. So we're going to do this section of the model, weighted overlay, suitable areas. We need con and majority filter. So use a conditional expression to extract only the optimal sites. It's been decided that you have to have a suitability of 9, the highest value, and so it's going to retain the value and everything else will be changed to no data. So let's go to here and add to this model. Let's go and add to it a conditional. Conditional. So we put that in. And suitable areas is going to go to conditional. And for some reason, conditional now shows nothing. So click the input conditional raster. Click suitable areas. Okay, so you don't connect it that way. You want to choosing model variables. Although choose variables in map, the input will be variables in the map view. Drop down this choosing model variables and connections for variables and choose variables in the map. So it looks like we have to go to condition and create a condition where value is equal to 9. And then we can check that that's okay. It's a valid one. And then click the input true, raster, or constant value and click true raster or constant. True raster or constant. That's going to be the suitable areas. And then leave the value for input false blank. So if the condition is true, pixel equals suitable as 9, the value of the cells will be applied to the cells of the output raster. Alright, but what about the input conditional raster? It's the same thing, right?
Daddy,
yeah.
I need a marble to make a marble trap.
I don't have.
But I'm a marble trap.
So this one here, if you choose it in the map or the model builder, I guess we want to have it in the model builder. Choosing model variables will build connections between variables and tools in the model builder. All right. Accept that, and so this is what we have, suitable areas. Suitable areas. It looks like he's choosing it not in model areas, he's just choosing suitable areas. So I guess I'll follow what he says to do there. Check that. say OK, and the condition output is con weight. Rename the output optimal areas and add the display. All right, so we'll call this output optimal plus optimal areas. And then that leads to optimal areas right here. Let's go ahead and lay this out. And then we can run this. And we need to add it to the display. And there it is. When we look at the map, those optimal areas are only these that are brown. It's hard to see when you have brown. So I'm going to change the brown to a bright purple. Oh my. So those are the areas there in purple. Turn them off, turn them on. So it picked up the dark green, which is the optimal areas, and that's what it's using. All right, good enough. All right, so save this. Almost done, it looks like. And go back to here, and it says turn off the relevant layer and keep only the optimal areas. There are many single cells representing optimal locations. These 30-meter cells are too small for the school site, so you have to clean up using the majority filter rule. All right, so obviously, if we turn off everything else in here, and we turn off that, turn off all these different things, then we see where the optimal areas are for building the schools. Now, some of these, as they say, are too tiny, just 30-meter pixels. It's a 30-meter pixel, so you can't build a school there. And that's why we're going to use the majority filter. And so the majority filter for those little things. So we're going to go and we're going to bring in the majority filter tool and click the raster and accept the default and make 8. So in other words, here we're going to put in a majority filter. Let me go to my model, bring in the majority filter, and this optimal area has to go to the majority filter. And what we want to do in the majority filter is we want to say the number of neighbors to use is 8. And what that means is, looking here, 8 neighbors means it'll use all of the, I'm almost done with this, all the neighbors going around here. Still the first. And here's if there were 4 neighbors, so we want to use 8 neighbors so that we can get the number of neighboring cells to the kernel to filter the nearest neighbors, and that gives us a better result for it, so we can get around that queen and rook neighborhood. It's where a queen can move on a chessboard all over, and a rook can only move forward, up and down. So this is called the rook neighborhood. This is called queen neighborhood. We're using the queen neighborhood of 8. Accept the default. Use the majority as the replacement threshold. Means 5 out of 8 connected cells must have the same value for the present cell to retain its value. So it's going to eliminate stuff that's only 1 pixel for sure. Okay. And so it'll be filtered optimal areas. And coming back in here, majority is the replacement method. So we are doing majority. We're using 8. The output raster is going to be called filtered optimal areas, and we don't want the period there. That'll mess things up. All right, so filtered optimal areas there. Now, why isn't this showing up? Saying it doesn't like the name. Something's wrong. Because there's a space probably. It's very specific about these things. There it goes. So the name was messed up. All right, I hope that helps you if that messed you up. All right, so now when we apply the filter and run it, it runs and it's successful. And boom. So now we're not going to see it because, oh, we do see it. Optimal areas. There it is, because it is on the map. No, it's not. Add to the display filtered optimal areas. So I can get rid of this one. Okay. So filtered optimal areas. That's the filter. Oh, I see what happened. I should have kept the optimal areas. There it is. So you can see the difference. So the filtered optimal areas are all those, but the filtered optimal areas are just those. So some of these places here were too small to build schools, so we end up with that. Those are the ideal areas. All right, where are we now? Examine the layer, compare the optimal areas and optimal areas, filtered optimal areas and optimal areas, turn some of them off to see clearly. So many optimal areas that were considered too small have been removed. If you lose the layer in the map view, you can right-click on the layer in the contents pane and click Zoom to Layer. So in other words, there's a saying that if you didn't know where you were, then you can right-click here and say, I want to go to Zoom to Layer, and boom, you come right to that layer there. And then you can see the different optimal areas. And now there's some final processing to be done. Selecting the best site. We've discovered the optimal sites for building the new school. All the locations in the filtered optimal areas are suitable. The last step is to locate the best site out of the alternatives. The roads layer displays the roads within the town of Stowe. By examining the filtered optimal areas layer with the roads layer, you'll see that there are some suitable areas for schools that are not too close to roads within the town, and we want to exclude these by locating suitable areas that are intersected by roads. Then you'll create the best site based on the area. An optimal school site is larger than 10 acres or 40,469 square meters. So you're going to convert the filtered optimal raster to a polygon inside a geodatabase so you can use the area field that's generated. So select area by location. And they're going to tell us to do that without the model. I want to see what happens if we put this in the model. So select area by location. Maybe that's in the model, maybe it's not. Let's see. Select area. There is no select area by. All right, so that does not happen in geo processing. It happens here. Select by location. So the first step is to search for raster to polygon. That is what we're going to use and add it to the model. So we go to our analysis and tools and go to raster to polygon. There it is. Okay. And bring that raster to polygon in. Let's put this thing to the auto layout now. And my raster to polygon is going to go be connected to this. All right. And now that raster to polygon is in, we're going to click the filtered optimal areas, leave the default the field parameter as value. So in this filtered optimal areas is in, the field is value. What comes next? Accept the output feature parameter path, but change its name to opt area for optimal area, and leave simplify polygons. So go in here and change this to opt area, get rid of that period. It's going to be a problem. So I have to have underscore. It doesn't work either. When I had gaps before, it didn't work. Simplify polygon is there, and add to display and run the tool. So go there, go here, add to display. This one here is added to the display. We need to run this tool. It's going to ask this one to run because this one stopped. So let's rerun. Does the majority filter. Does the field optimal, filtered optimal, and then it ran the output polygon. So you can look at the map now and see that the filtered stuff was raster. See all those little edges? That's a raster. So when you zoom in and out, you get pixelated. Those are rasters, but we converted it to a polygon as a vector file, shapefile. It doesn't matter how much we zoom in. As you can see, they work fine. So those are the ones that we're going to be working with. Those nice polygons. And there's several of them in different locations. There's also some up here. But we want to get stuff that's near the roads. Not until I finish this.
How many minutes?
So now the trick is to, we've run the tool select by location. So although you can add the selection tools in your model, we'll do them in geoprocessing tools outside the model builder. I want to put them in the model if I can. I want you to know you can run it outside. So in the contents pane, move all layers except land use, elevation, destination, roads, rec site. So everything except land use, elevation, destination, roads, rec site, school, slope, output, and optimal layers. So let's do that. Let's go here and say we don't want this anymore. It's filtered optimal layers that we want, right? Optimal area layers. That's the output polygon. That should be called optimal layers, actually. What was it called? Hold on. Opt area. Opt area. Right. They want it to be called opt area. And that's a filtered opt area. But we'll call it opt area. And let's rerun it. Let's get rid of this. And rerun this. Alright, so there's our opt areas as the polygons that we wanted. We don't need this anymore. We don't need this anymore. We don't need this. We don't need this. We've used all these. They don't need to be displayed on the map. Slope, we do want to keep. Distance to recreation, we don't need. Land use, we might want to keep. And we want to keep land use, I suppose. We do want the elevation. We want the schools. All right. So, I don't know. See the slope. See the land use. Turn that off, but I'm going to keep them. All right, let's just use it like that. And then let's come in here and say, so we have land use, we have elevation, we have each of those rec sites, and everything like that. So we're going to select by location under the map tab. Shift to the map tab and open select layer by location. So we come in here and we say under map, select by location, and the input feature is going to be the opt area, and it's going to intersect with the roads layer. Okay. So we're going to say to it, input feature is the opt area. Should be in here. Opt area, there it is. So that's going to be the input, and the road is the intersect. Selecting feature is the roads, and then search distance is going to be nothing. Alright, so opt area, intersect roads, new selection. And then there's a problem loading that page. Wonderful. Let's try. Okay. There we go. Alright. So the new selection. And say apply. And now you can see that it's selected these ones here because they're closer to the roads. These here are closer to the roads. They intersect. You can see that the road goes right through each of these, whereas it doesn't go through any of these. So that you'd have to build a road, and that would be expensive. So even this one barely touches, so it's not included, whereas the road goes right through this. And so that's the criteria that we're using. Where does the road actually touch as the first thing? Then, having that selection, we're going to select the layer by attribute, and we're going to select a subset from that current selection. And so here we say select by attribute. The input row again is going to be the optimum area. The selection type is going to be select subset from the current selection. The current selection is the ones that intersect with the road that are in blue, and then it's going to be where the shape area is greater than 40469, and that is 10 acres, 40,469 square meters. And so where the shape area is equal to or greater than, rather, and then put in here, I don't doubt that there's a, you don't need to do that because we know what we're looking for. 10 acres, 40,469, 469. All right, let's see if that pans out. It is a valid expression, so that is in the data. And then click OK and examine the results. All right, so we go OK to that. And those are the ones, that one there. And looks like that is the only one. So that's the optimal site for the school. It's big enough for the school. So finally, search and open the Copy Features tool. Click the Input Features, click the Browse button, navigate to Stow, and store it instead of Scratch. So we're copying those features. So that feature there, which is selected, we go to Copy Features. There it is. And we're going to run it, I guess. So search and open Copy Features, click the Input Features, and do the optimum layer. So I'm going to run it and say we want the optimum area that we had. And the output feature class, it has a selection, so it's going to process that. The output feature class is going to be browse and navigate to Stow, so it goes into there and not Scratch. So go to Stow and give it a name, and we'll call it Optimal School Site. That's going to be the optimum, and it's going to go right into this lab and into Stow's database, geographical database. So I think all I have to do now is run it. And then, final site we want to call it. Okay. So we're leaving the scratch thing. We're going to call this final site. All right. And then run it. Okay. And now when we look in our catalog, if we were to turn this off, and we would see the final site is there. That's the only site of relevance. And it is now in our stow as final site. It's not in our scratch. Stow is where we started. Remember, we started by putting all of this data into the map, and then we create the scratch thing to do our work in. But now we have this model. The only other thing I want to see about this is there a way to run this in the model? So it said that we could do this select layer by attribute and location. Though you can add the selection tools in your model. So how would you add the selection tool in the model if we didn't want to have to go through this again? We would go to the tools, and we would have select. And then we probably would take select and drop it in, and take the opt area, and we'd say select from there, and it would be where, select a field. Right, so what were we doing? Let's remember what we were doing here. Select by location was select layer by location, and then we were saying where intersect rows. So that's what we would add in this then. It would be where the shape area intersects. I don't see any intersect in here though. So environments, properties, precondition. Yeah, I don't know how to do that yet, and it's not part of the exercise. But it would be cool if we could do the intersect. I don't know if that's using SQL. Shape area equals, no. No. It's a sequential query language, and we don't need to do that. So there's a way to do it, and select by location. Sorry, I used the wrong selection tool. That's my problem. So let's do it again. Select layer by location, and then go to here, and say where the area intersects the roads. There we go. And make some new selection. Yeah, we can do that. We can make a new selection on that. And the search distance was nil, right? I mean, search distance isn't even a thing there. So it's just a selection that way, and it intersects the roads. So that's what we did there. And so if I run this, then I get this to be added to display, and this to be added to display. So my final site is not as interesting. So there are those. Okay, so it did exactly that. It did those ones we saw before that are intersecting. It's just now part of the model this time. And let me go into Model Builder and put this in the auto layout, and we move closer to here. And then finally we had select layer by attribute. And so we would take the output layer and go from there. Let's click on this. Go to there. And there we would say to it, we want that new selection where the shape area is equal to or is greater than 40, whatever it was, 40,000 something, 469. So 40469, and check that out. Good. And then the selection type is a new selection. It was not, it was select subset from the current selection. It's that selection there. Say OK, and that has to be rerun then. So let's get rid of this. And let's get rid of this. And let's rerun. Run this, and it'll have to pull from the other. Okay, and then we add this to the display, and we have just that. That's the only one that comes up. And it seems like it still displayed everything, but it made it selected. So the final step is to take that and do the copy features. So we would do copy features in the model. And take that and drop this in. And move that to there. And the copy features information is going to be to take this input features, which is the whatever came out of there, the raster Q filter layer 2, and then output a feature class in stow that we would call final site from model builder, just to distinguish it from the one that we got when we did it by hand, so to speak, in stow. And run it. And so when we get to here and we run, it should give us a final site that is there. Well, looks like we've done it, and we have a model that will work. When we get to the next exercise, part B, we don't have to reinvent the wheel. A lot of this is already there for us to use. So hope that was helpful if you're following along with the exercise, and we'll see you in the next one as we tackle part B, suitable wolf habitat. Happy trails.